All right, hi again. So today I'm going to do the 12 to 15 minute kind of mini seminar on what I looked at for my literature review. Um, my area morphed several times over the semester, kind of trying to figure out an area outside of my research that I was really passionate about. And after seeing a presentation at ASAS Southern section, I kind of stumbled into the idea of tenderness and cooling from a lady who presented on trying to do artificial insulation on goat carcasses to prevent cold shortening and therefore increase tenderness. Um, when looking at that, in my estimation and from what I found, there's less opportunity for that literature review wise because it hasn't been very successful and there hasn't been many publications that I could find about it. So it kind of morphed again and went towards tenderness, but the general major effectors post mortem, as well as consumer perceptions, and kind of moved towards my research to a certain extent, looking at fat content, palatability, and consumer demands as well. So um, I started off looking at beef audits, and they're really from the 2011 North American Tenderness Survey by Howard and others in 2013. There was really no improvements from the 1990 survey all the way to 2011. So some people may say that means we've been doing well since 1990, but I'm going to guess that the better majority of people are going to say that that means we just haven't improved enough. Um, and likewise, with the NCBA's paper published in 2005, concerns from the packing industry include quality grades aren't as good, tenderness isn't as high, and marbling isn't as high either from the most recent one. And that's included in the overall perception of the beef industry as well. So we just haven't been making as much strides as we were, and we've got some room to go. And I think part of it stems from this is speculation, but especially tenderness and marbling, we've seen some improvements in growth promotants since the early 90s, which maybe had us take a step back as those were implemented. So now we're moving forwards from there, trying to regain our tenderness from those improvements in quantity of production. So to start, we've already discussed a lot of these post-mortem effects in class, but we'll try and touch on them shortly. pH, we know in live muscle is right around 7. It's very tightly regulated. Post-mortem, however, that pH decreases, and we like to target 5.3 to 5.8 ultimate pH in meat. Now, this pH decline is a result of continued glycolysis in a anaerobic environment once we've exsanguinated the animal to cause death. And those tissues, although the organism is dead, the individual tissues are trying to live on. And so the muscle tissues, they're continuing glycolysis to maintain that energy production. And this final ultimate pH is probably, it depends on animal, and mostly animal because of muscle type. So pork, we know, has been branded the other white meat, and it has a larger proportion of white muscle fibers. White muscle fibers obviously they use more glycolysis, or excuse me, they use more glucagon. They use more glycogen, which means they have higher glycogen stores, and therefore they can continue and have an elevated rate of glycolysis for a longer period of time, which means that they produce a greater amount of ATP post-mortem from glycolysis, resulting in a greater decrease and more rapid. So they reach their ultimate pH in 6 to 12 hours, whereas beef, that's primarily red fibers, takes anywhere from 18 to 40 hours. And we'll talk about this in a little bit, why this is important. As I said, decrease is a result of glycolysis and glycogen stores. And pH has been known to affect water holding capacity. And this comes into play with PSE, or pale, soft, and exudated pork versus dark, firm, and dry pork, or dark cutter and beef. As that pH drops very rapidly, it nears the isoelectric point of those amino acids and allows them to line up and bind closer together, leaving less room for that free water in the meat. Conversely, dark cutters or dark, firm, and dry is when pH doesn't drop to that ultimate range of 5.3 to 5.8, and so they actually have improved water holding capacity from normal. Now we can see here in this chart, I found these pictures, I think they're really good, from the Canadian Center for Swine Improvement for this seminar specifically, but on the left we can see that dark, firm, and dry reaches its ultimate endpoint quickly, and it's very elevated. And this is because the animal maybe had some pre-harvest stress, and that causes the animal to use up the glycogen stores more rapidly before harvest, and then there's not enough left to continue glycolysis for a normal period of time in order to decrease the pH down to where it should be. Now, similarly, if it has too much, or if it's just stressed and it's constantly using that glycogen rapidly, then we can have PSE, where it drops too quick. And we can see here that it may drop down to 5.5 or below in 3/4 of an hour. And when that happens, the ultimate pH winds up too low, and there's excess purge, and the color is poor as well. We can also see on this chart acid pork, as well as the normal desirable pH decline too. And this is going to cross over to the picture on the right here, where we can see that the middle two pictures are going to be around the desired ultimate pH for pork. And as we increase, we can see that the pork becomes darker and darker, and that would be DFD pork at the top. Whereas similarly, as we decrease, we move down the pH scale of ultimate pH, and at the bottom, that would be clearly PSE, very exudative, very pale, probably very soft as well. Now, rigor mortis is a result of pH decline, more or less, because as pH decreases with the use of ATP, as ATP decreases, rigor mortis sets in. And rigor mortis is just the irreversible contraction of muscle post-mortem. There's 3 stages as we've talked about. There's the delay, where there's still enough ATP to relax the muscle fibers. Onset, where there's less and less, and so in increasing fashion, those muscle contractions aren't released, aren't relaxed. And then finally, in completion, there's no ATP left, and all those muscle contractions are permanent. And this, again, similar to ultimate pH, is dependent on the glycolytic potential of that muscle. And here from Lowry's 1953 paper, this specifically is in horse, but we can see that the hollow circles are going to be ATP. So we can see that for a while it's maintained, and then it starts to decrease fairly rapidly. And that's because for a while we have enough glycogen to maintain relatively similar stores for a while, but then as we run out of glycogen, we run out very rapidly to essentially no ATP left. Creatine phosphate is the hollow circles, and that's going to be similar to ATP, as that is used to replenish ATP from ADP. Or excuse me, that's the hollow triangles. The hollow circles then are pH. And we can see that that is even more similar to the decrease in ATP, because it is a direct result of ATP being used to pyruvate, and then pyruvate being changed to lactic acid. And then lastly, we can see that the black circles are the extensibility of the muscle, and it is 100% for almost 2 hours. And then we can see that once rigor mortis begins to rapidly set in and be complete, that muscle extensibility shortens very rapidly. And we can see that it goes from 100% extensibility to being able to move it to less than 20% very quickly. There's also a few things we've talked about with abnormal rigor. Thaw rigor is where rigor does not have a chance to form prior to freezing. Freezing causes a massive release. The sarcoplasmic reticulum has holes punctured in it, and it releases all this calcium. So once that muscle thaws, there's a massive contraction in that muscle, and there's no ATP left to release it. So causes severe shortening. Dr. Selzlini talked about freezing a muscle, an unattached muscle, and then showing that in class as it thaws, it can shrink up to 80%. Similarly, on the other end, leaving muscle too hot for too long allows rapid depletion of ATP, resulting in severe and strong rigor formation early. And again, rigor is the irreversible contraction. And so increased contraction results in thicker, shorter muscle sarcomere units that are tougher to chew through and therefore tougher within palatability ratings. Now, cooling rate can also play a factor in tenderness. This is, like I said at the beginning, this is where I was kind of very interested in looking at, if we go too quick, it's important to reach certain temperatures in order to achieve food safety. Going too slow or leaving the deepest parts of the carcass too hot can result in bone taint or bacterial spoilage around the bones. So it's important to get to that below 40 point. However, rapid decline of temperature prior to rigor can result in the phenomenon cold shortening. And I know we've discussed this too, but cold shortening is just the shortening of muscle fibers and resultant toughening of the meat products as a result of chilling carcasses below 10 to 15 degrees Celsius before the onset of rigor. And so it's dependent on muscle type. White, we see a little bit more resistance than red because of that drop in ATP quickly, and therefore rigor sets in earlier. Pork is more resistant to cold shortening than beef. But we've also discussed all kinds of methods on prevention. Electrical stimulation from New Zealand was huge and has offered a lot of prevention for carcasses that maybe don't have the quality fat thickness, appropriate insulation to prevent the rapid chilling of carcasses, at least in beef, but also temperature conditioning where they rapidly chill carcasses to 15 degrees C, but then hold it there until rigor has a chance to set in, and then rapidly move it down closer to the holding temperature or aging temperature. Now, as I said, I steered away from kind of the post-mortem effects also to look at maybe the compositional effects. And I won't get into all of the collagenases and collagen content and that kind of stuff. I feel like that's fairly well known, and I won't use the short 15 minutes to discuss this as well. But fat content has been shown to directly affect palatability. It plays a role in tenderness, flavor, and juiciness as well. And from my slides, as well as other portions of the class, Savelle and Cross's theorems of fat bettering tenderness and palatability have been well discussed. But again, bite, strain, and lubrication, it all deals with the force required to chew through the meat, lubricating it, as well as insurance for cooking. But interestingly, consumer preferences is really where I started to getting excited during this lit review. And we've already talked about this Wheeler paper, but I think it's very cool. It looks at both Bos Taurus and Bos Indicus breeds and the differences in tenderness there across the marbling scores. And so they looked at shear force values, but then they also did sensory panel scores for tenderness, juiciness, etc. And interestingly enough, even though the industry just barks a storm about marbling being the end-all be-all, especially on pricing of carcasses, marbling really only scientifically explains 5% or less of the palatability variation within grades or between grades. And so they suggested, and I agree with this, there needs to be a better, more direct measurement for USDA quality grades. Now, in 2012, again, you've probably seen this paper, but O'Quinn and others from Texas Tech looked at the different American A maturity quality grades, as well as Wagyu and Australian, and looked at the quantity of fat, and then looked at consumer ratings of palatability characteristics. And they found that, yes, flavor does play a key role, juiciness, aroma, that kind of thing. Flavor plays probably a bigger role than we initially thought, because from early research, we've really thought that consumers are most interested in tenderness. But we know that flavor doesn't, or fat doesn't affect tenderness as much as we thought. So maybe flavor plays a bigger role than we thought. And we can see that this paper does a really good job of explaining that maybe there's a minimum of fat that as long as we achieve that, we're going to be safe. We're going to make consumers happy. And so although higher quality grades, prime, Wagyu, high choice, low choice, they were graded above select and standard and Australian beef in the consumer ratings, there really wasn't much of a difference between low choice and prime, but there's a huge price difference. You know that if you've been to the store. And actually, Wagyu actually fell down more similar to low choice and select in some, because it was too fat. And so there may be a minimum we need to look at hitting of around that 3 to 4.7% fat range, rather than trying to make it an exorbitant amount of fat in these beef carcasses. So to conclude, greater improvements in tenderness can be and will continue to be controlled for and improved using pre and shortly post-mortem effects with pH drop, rigor mortis formation, and cooling. Fat content does affect the tenderness and palatability of meat, but it appears that there is a lower critical value that we need to start trying to find specifically, and reaching that point. Consumers do continue to value tenderness, but personal preferences are increasingly important, especially when it comes to that fat content, because somebody who may be more health conscious prefers something like a low choice or select steak rather than that Wagyu, because tenderness might be similar, that they can detect, and therefore they're going to go on the health side of less fat. So I think that further work is warranted to look at maintaining the proper pre and post-mortem handling, but more importantly, altering flavor profiles at or near a minimum fat content of beef to regain the modern consumer's beef demand that I feel like we're starting to lose with false science from Science Babe, etc. So there is a moving demand towards healthy beef, and so maybe trying to hit that minimum fat content and altering flavor profiles to catch those millennials that maybe have moved away from the heavy beef consumption. So with that, please address any questions to me, and look forward to answering them. So thank you much.